Welcome to the deep dive. Today we're jumping straight into what I can only describe as a massive disruption currently tearing through the AI space right now.
Yeah, it's the big one.
Huge. So our source material today is this highly detailed tech review and script from a platform called OscarAI, and the entire focus is on Yuan 3.0.
Right.
Specifically, we're looking at its Flash and Ultra models. These are engineered by the Chinese AI developer yuanlab.ai. And the mission for this deep dive is basically to figure out exactly how this open source model is successfully challenging established Silicon Valley giants.
Which is no small feat.
Not at all. And the twist here is that they aren't doing it by just brute forcing a physically larger, more power-hungry model. They are doing it through this radical, most surgical computational efficiency.
Yeah, and that efficiency targets two of the absolute most critical pain points in the frontier AI industry today.
Mm-hmm.
First, there's the problem of massive computing costs. I mean, renting out GPU clusters to run these trillion-parameter models is just financially unsustainable for most businesses.
Oh, for sure. It burns through cash.
Exactly.
Okay.
And the second issue is what the industry calls overthinking in reasoning models.
Right.
This is when an AI generates thousands of unnecessary chain-of-thought tokens before actually delivering the answer to your prompt.
Right. It's just rambles.
It does. And the OscarAI material suggests Yuan 3.0 introduces a paradigm shift on both of these fronts. It's executing complex reasoning with a mere fraction of the computing power we previously thought necessary.
Okay, let's unpack this. Because the development timeline detailed in the source is incredibly aggressive.
Very fast.
Yeah, the Flash model of Yuan 3.0 dropped in late December of 2025, and then the massive Ultra model launched just 2 days ago on March 4, 2026.
So fresh.
Super fresh. And to understand how they are achieving this level of performance so quickly, we have to look at their core architecture, which relies on a mixture of experts or MOE design.
Right, the MOE architecture.
Yeah. And the OscarAI review uses this brilliant analogy here that makes the mechanics very clear. So imagine a superhero team like the Avengers. In a traditional, dense AI model, every time you give it a prompt, the entire massive brain lights up.
Every node.
Every single parameter fires. It's like sending the entire Avengers roster, including the Hulk, just to hack a computer terminal.
Which is entirely unnecessary.
Right. It gets the job done, but it wastes an immense amount of energy and collateral resources to do it.
Whereas with a mixture of experts architecture, you have a routing mechanism. It analyzes the prompt and only activates the specific neural network experts trained to handle that particular type of query.
Exactly.
So sticking with the analogy, you just send an Iron Man to hack the terminal while the rest of the massive network just stays dormant, conserving compute power.
And the hard numbers on this are staggering when you look at how Yuan 3.0 actually implements it. Let's break down the Flash model first.
Let's do it.
So Flash has 40 billion total parameters. But because of that MOE routing we just talked about, it only uses 3.7 billion parameters during inference.
That's incredible.
Right. That means when it is actively generating an answer for you, it is activating less than 10% of its total capacity.
And then you look at the heavyweight, the Ultra model, and the scale becomes even more impressive.
Yeah.
Ultra was originally pre-trained on 1.515 trillion parameters. And through some techniques we'll discuss shortly, they pruned that down to a final size of 1.01 trillion parameters.
Still massive.
Still huge. But the crucial metric is the active parameter count during inference. When you actually query Ultra, it only activates 68.8 billion parameters.
Wow.
Yeah. It possesses the vast, latent foundational knowledge of a trillion parameter behemoth, but it operates with the agility and the compute cost of a mid-size model.
That is wild.
If we connect this to the bigger picture, this fundamentally alters the economics of artificial intelligence for businesses.
How so?
Well, you no longer need to pay exorbitant API fees to ping a massive monolithic model just to parse a spreadsheet. You gain access to a massive reservoir of computational intelligence, but you are only paying the computational hourly rate, essentially, for the specific subset of experts actively working on your problem.
Okay, yeah. That reduction in compute overhead is massive. But it only solves half the problem if the model itself is still generating wasteful outputs.
Right.
Which brings us back to the overthinking issue.
No.
The OscarAI review uses this really relatable analogy of a chatty friend to explain how current large reasoning models operate.
I love this analogy.
It's so good. We all know someone who, when you ask them a simple yes or no question, feels compelled to detail their entire morning routine.
The traffic on their commute.
Yes,
Yeah.
their philosophical outlook on life, all before finally answering yes.
Yeah.
And current models like DeepSeek R1 or OpenAI's O3 often exhibit this exact behavior.
They do, and there is a structural reason for it. Those models are designed to use chain of thought processing.
They generate tokens to essentially talk to themselves and map out the logic before finalizing an answer.
Which sounds good in theory.
In theory, yes. But the problem is, because AI services generally charge by the generated token, a model that generates 20,000 tokens of internal monologue just to solve a basic logic puzzle is burning through your budget at an alarming rate.
Totally. So to cure this, the researchers behind Yuan 3.0 introduced two heavy-hitting scientific mechanisms. These are detailed in their ArXiv paper, specifically paper 2601.01708.
Right.
The mechanisms are RAPO, which stands for Reflection-Aware Adaptive Policy Optimization, and RRM, which is the Reflection Inhibition Reward Mechanism.
Odd acronym.
A lot of acronyms, yeah. But simply put, instead of just hoping the model gets more concise, they fundamentally altered the training incentives. They introduced a penalty system that actively punishes the model for rambling. Yeah. During training, the system gets a reward for finding the correct answer, but it gets penalized if it goes down unnecessary philosophical rabbit holes or generates excessive chain of thought tokens to get there.
But there is a significant risk when you implement a penalty like that.
What do you mean?
Well, if you punish a reasoning model for thinking too much, you risk making it stupid.
Ah.
It might start giving short, concise answers that are completely wrong because it didn't take the time to map out the logic. The breakthrough with RAPO and IRM is that they managed to heavily penalize verbosity without degrading the model's logical accuracy.
That's a tough balance to strike.
It really is. It essentially forces the AI to find the most efficient logical path to the correct conclusion.
And the verified benchmarks for the Flash model demonstrate exactly how well that worked.
Let's hear the numbers.
Okay, so by utilizing this reward and penalty system, the inference tokens, meaning the actual length of the model's output, are reduced by up to 75%.
75%, that's huge.
Huge. That is a direct 75% reduction in potential API costs for an enterprise user.
Right.
What happens to the accuracy? Let's look at AME 2024. That's a notoriously brutal math and logic benchmark that usually trips up language models.
Oh yeah, that's a tough one.
Not only did the Flash model's precision increase to 47.92%, but the output length drops from roughly 13,700 tokens down to just 7,505.
Wow.
Yeah, the model actually got smarter while cutting its required word count almost in half.
And that trend continues across other difficult tests too. Like on the Math 500 benchmark, Flash scored an 89.47% using only 1,777 tokens.
That's incredibly low.
It is. The OscarAI analysis notes that competing models are regularly using double or even triple that token count to achieve comparable scores.
Unbelievable.
And furthermore, the newly released Ultra model pushes this efficiency even further. Ultra's implementation of the APO and IRM techniques improves its training precision by an additional 16.33%, while simultaneously reducing the tokens used by another 14.38%.
So it scales.
Exactly. It proves that as the model scales up in size, the mechanisms enforcing conciseness actually become more effective. Here's where it gets really interesting. Because the source review highlights an architectural innovation entirely exclusive to that massive Ultra model.
Oh, this is my favorite part.
It's a process called LAEP, or Layer Adaptive Expert Pruning. And this directly addresses the bloat that normally happens when you train a trillion parameter model. We discussed the mixture of experts architecture earlier routing tasks to specialized subnetworks.
Right.
Well, during the intense pre-training phase of Ultra, the system actively audits itself to hunt down what the researchers call lazy experts.
Yes, the lazy experts. And just to clarify, that term refers to nodes or subnetworks within the model's layers that simply aren't pulling their weight.
Right, the slackers.
The slackers, exactly. During training, the system tracks activation frequencies and the contribution each expert makes to the final accuracy. If an expert is rarely activated, or if its activation doesn't meaningfully improve the model's output, it is deemed inefficient.
Makes sense.
So LAEP ruthlessly prunes these inactive experts out of the architecture, layer by layer in real time as the model trains.
And the results of firing all those lazy experts are dramatic. This pruning process is exactly how they took that initial 1.515 trillion parameter structure and cut it down to the final 1.01 trillion.
Which is a 33.3% reduction in total parameters.
Without losing the core reasoning capabilities.
Right.
And because the computing cluster is no longer wasting cycles calculating gradients for ineffective nodes, the entire training process becomes 49% more efficient.
That is a massive gain in efficiency.
It really is. And alongside LAEP, the source also notes the use of localized filtering-based attention, or LFA.
Right, LFA.
This mechanism prioritizes local dependencies in the data streams, which makes the model highly effective at processing complex real-world semantics, and it actually gives it exceptionally strong performance in handling the Chinese language.
And all of these architectural choices, the MOE routing, the RIPO token reduction, the LAEP pruning, they all point toward a singular goal, hardware accessibility.
Exactly.
Because the model footprint has been compressed so intelligently, it supports 4-bit quantization right out of the box.
Which is huge for developers.
Huge. For those working in deployment, 4-bit quantization essentially compresses the precision of a model's weights. It drastically reduces the amount of VRAM needed to hold the model in memory, and it does that without significantly degrading its smarts.
Exactly. And I want to pause here and ask you, the listener, to really consider what this actually means for your daily workflows. The OscarAI review hammers home that this technology is built to run on standard frameworks like VLLM.
Right.
You don't need a multi-million-dollar cloud instance to run a frontier-level reasoning model anymore. You can run highly advanced AI locally on accessible, consumer-grade enterprise hardware.
That is a massive shift.
A huge shift for developers, IT departments, and independent startups. But hardware accessibility only really matters if the model can actually handle real business tasks. It isn't just about text generation.
Right. The real-world utility of Yuan 3.0 lies in its multimodality. The architecture utilizes an intern-VT vision encoder that feeds directly into that highly efficient MOE backbone.
Meaning it handles images. Exactly. This creates a unified system capable of ingesting high-resolution images, incredibly dense document formatting, and complex tables. It is designed specifically for enterprise environments that are drowning in messy data.
Which is almost every enterprise environment.
Pretty much. We're talking 100-page financial reports or sprawling data dashboards that mix text, charts, and graphs.
To see how well it handles that messy data, the OscarAI script logically grouped and analyzed verified benchmark scores from GitHub and MarkTechPost.
Let's hear them.
They put Yuan 3.0 up against the undisputed titans of the current landscape: OpenAI's GPT-4o, Anthropic's Claude Opus 4.6, and DeepSeek V3.
Heavy hitters.
The heaviest. And instead of just reading down a spreadsheet, let's look at the delta, the actual performance gaps in these business-critical tasks.
Okay.
Take Docmatics, for example. This is a multimodal ARSH benchmark. It tests how well an AI can read a heavily formatted document that mixes text and images and then accurately answer questions about it.
Very common real-world use case.
Exactly. The source cites GPT-4o's score in this benchmark at 56.8%.
Okay.
The Yuan 3.0 Flash model hit 65.07%, and the Ultra model leaped all the way to 67.4%.
That is a massive jump.
In the context of AI benchmarks, a 10-point jump over a frontier model on a task this complex is a generational leap.
And we see a similar dominance in ChatRag, which tests text-based retrieval augmented generation. Flash scored 64.47% and Ultra scored 68.2%, with the source noting that Ultra dominated 9 out of 10 specific tasks in that category, again outperforming GPT-4o.
Impressive.
Very. And an MMTab, which is a benchmark specifically designed to test an AI's comprehension of complex, multi-layered tables.
This is a notorious weak point for language models.
Right, they usually struggle there. But Flash achieved 58.29% and Ultra reached 62.3%, surpassing both GPT-4o and Claude. Finally, in SumEval, which evaluates the ability to generate accurate long-form summaries from massive documents, Flash scored 59.31% and Ultra hit 62.8%.
What's fascinating here is how we synthesize the impact of these numbers. We are not just looking at a new model that marginally edges out the competition on a leaderboard.
Right. Yuan 3.0 is achieving these frontier-level scores while using a quarter to a half of the computational tokens that the other models require. It is producing demonstrably better work while expending significantly less effort to get there.
That's the real story.
It is. And perhaps most importantly, for the developer ecosystem, both the Flash and Ultra models are entirely open source. They are released under a commercial license that requires no special corporate permission or ongoing API tolls to utilize, provided standard usage rules are followed.
Which is a game changer.
So what does this all mean? The enthusiasm in the Oscar AI review is palpable, framing this as a complete revolution in efficiency. But we have to look objectively at the practical hurdles of deploying this in the real world.
Absolutely.
The source material outlines 5 major challenges and reality checks that come with this disruption. The first is the hurdle of Western and global adoption. While the model is open source, the primary documentation and community support currently exist in Chinese and technical English.
And that language barrier presents a significant friction point for global scaling. Because the barrier to entry is suddenly so low, developing tech hubs are going to jump on this technology. The OscarAI review specifically highlights Latin America, pointing to places like Colombia with its rapidly growing developer ecosystem.
Right.
These are regions primed for this kind of accessible, low-cost enterprise AI. But for that adoption to happen smoothly, the global open source community must step up to translate the documentation and fine-tune regional models for Spanish and other local languages.
The second challenge is residual overthinking. While the RAPO and IRM mechanisms are incredible at reducing token bloat by 75%, they haven't completely cured the chatty friend syndrome.
It's still a language model at the end of the day.
Exactly. The source material warns that when faced with ultra-complex multi-step edge cases, the model can still get lost in the weeds. It might generate unnecessary tokens or hallucinate entirely. It is highly efficient, but human validation and oversight remain absolute requirements in an enterprise setting.
Challenge number 3 is simply the competition. The established titans are not standing still. OpenAI, Anthropic, and Google command vast resources and deep pools of engineering talent.
They aren't just going to give up.
Right. The question the source poses is whether Yuan Lab can maintain this specific architectural lead, or if the massive Silicon Valley players will simply reverse engineer and integrate similar layer adaptive pruning and advanced MoE routing into their next iterations.
The fourth reality check deals with regulatory and ethical risks. And this is the inherent double-edged sword of the open source movement.
It is.
When you place a highly capable frontier-level reasoning model into the public domain, the end user assumes total responsibility for how it is utilized. We have to report this impartially. The source points out that as this technology permeates those rapidly growing tech sectors, again, referencing regions like Latin America, local legal and regulatory frameworks need to catch up quickly.
Right.
The potential for misuse scales exponentially when enterprise-grade AI can be spun up on a local laptop without any centralized corporate oversight.
And finally, the fifth challenge is training scalability. We have focused heavily on how cheap and efficient the model is during inference, when you are actually running it.
Right.
However, the initial creation of the model is a different story entirely. Pre-training a massive 1.515 trillion parameter architecture from scratch, even with LAEP actively pruning lazy experts to save compute cycles, requires a staggering amount of infrastructure.
It's still a massive undertaking.
Yes. Running the final product is cheap, but building the foundational weights still demands resources that only a handful of entities globally possess.
But even with those significant hurdles, it is easy to see why the source material frames this as an unprecedented opportunity. I mean, think about the economic implications for an indie developer, a bootstrapped startup, or a regional IT department.
It's revolutionary for them.
It is. If you can download an open source model that outperforms GPT-4o on parsing messy, complex business documents, and you can run it securely on your own local server because it uses 75% less computational overhead, you fundamentally change the business model of your company.
Yeah.
You remove the cloud API dependency entirely.
It's a textbook example of technological democratization. The core takeaway from synthesizing this OscarAI deep dive is that the era of simply scaling up parameter counts is ending.
Right. Bigger isn't automatically better anymore.
Exactly. For years, the industry assumption was that a smarter model strictly required a bigger, more power-hungry data center. Yuan 3.0 proves that the new benchmarks for success in the AI race are radical efficiency, intelligent pruning mechanisms, and aggressive token reduction. It proves that frontier intelligence can be pushed out of centralized, multi-billion-dollar cloud facilities and directly into the hands of the end user.
And a quick reminder to you, our listener, you don't have to take our word or the source material's word for any of this. Because the project is fully open source, the model weights are available right now.
Go try it.
Yeah, you can go to Hugging Face under the Yuan 3.0 AI repository or visit ModelScope and download them today. You can pull down the Flash or Ultra models, configure them with 4-bit quantization on your own hardware, and verify this hyper-efficiency firsthand.
Before we wrap up, I want to leave you with a final provocative thought to mull over, building on the implications of what we've unpacked today.
Let's hear it.
If the most hyper-efficient open-source AI models are now successfully being engineered to run on consumer-grade hardware, what happens to the traditional moat of big tech companies? If anyone, anywhere, can run a frontier reasoning model on a standard local server, does the true value of artificial intelligence shift away from who builds the model to who has the most unique, highly specialized data to feed it?
That is exactly the kind of question we love to leave you with. Thank you so much for joining us on this deep dive into Yuan 3.0, the mechanics of layer adaptive expert pruning, and the future of open source efficiency. We hope you found this exploration as fascinating as we did. Keep questioning, keep learning, and we will catch you on the next deep dive.